Hello. For the past few months, I've been working on a game engine. Really, I've been working on this game engine for the past few years, and I'll get more into the technical details of how this engine works as we go along. But I want to use this engine today to make a very simple demo for a game that may end in 2000. The title of the game may end in 2000, the number 2000. I won't tell you what the first word of this game is. But today we're not making any kind of a game, we're just making like a little animation using this game engine. It's just a simple animation, and it's going to be designed for a video format of this aspect ratio for certain reasons. And in this little animation, there's going to be a house, and may also be a little tree, just one perhaps. And then there's going to be, I don't like curves because the tooling sucks. It's very difficult to do user input for curves. It's difficult, and that's something that I'm going to have to figure out. And at the end of this curvilinear shape, there'll be a big shopping mall. Yay, come to the shopping mall. And then, in this little animation, there will be a person, which will just be represented by a box, because everything's going to be boxes in the first version of this animation, except for this little curved part here. Everything else is just going to be boxes for now. And this guy, he comes out of his house, and he has a car, which is also going to just be a box, parked in his driveway. And the car will come out of the driveway, and will follow this curved path here. And then it's going to go into the mall, and it's going to park. And it's going to stay in the parking lot, it won't disappear. And then the guy will get out of his car, walk through the parking lot, and go inside the mall. Just a little animation, not a game. Just a little animation. So how do we go and do that? Okay. Have a background color. Very minimal. Go ahead and take a look at the code. Here is the beginnings of the game engine. It's very simple right now. You initialize it. You also initialize a window. Set some input callbacks. Set up some initial data, including the camera position, which we're probably going to adjust. And then you run with this task generator. Game engine is based around these tasks. I have to add a new task to handle drawing. Task the 2000 draw. And enable it. All tasks have to return 0. In the future, maybe this will represent a status code. Did the task run correctly? I don't know. And the tasks get this parameter t, which is how they access the game state and do basically everything. T is of type cursor node. Now, how do we draw? let's go take a look at our reference here. We have Pong. And okay, first we have to create a mesh. So U32 shopping mall equals 0. U32 house equals 0. Let's call these meshes. Mesh car. The road is going to come later. The person, everything else, that's going to come later. But let's just start with shopping mall house car. We can create these meshes down here. Let's see. Equals, and then we're going to procedurally generate them using this box function that I just made. And I haven't tested it yet, so it might not look correct, but we'll see. The dimensions for the shopping mall: 50, 100, 20. And we're going to make everything kind of a dull gray color, because this is developer art. The car will be much smaller, of course. Let's see how that looks. I think that might be a bit big. But we'll see. And everything's going to be the same dull gray color. We're just going to store these in the global scope for now. And then we draw them. We pass the draw our t parameter. Mesh shopping mall. I think we have to put in a location. Let's see how we do it over here. Yes. And for some reason, we're not storing our location in a vector yet. We're just, passing the XYZ as parameters, and the fourth parameter is a rotation. Okay. So I could put the shopping mall at 20, 50, 0, 0. Mesh car, mesh house. Now this draw task gets called every frame. I actually have to, I think it's draw clear, yes. And rendering happens in a separate task. There's a standard render task. So drawing just tells the game engine, draw this particular mesh at this location with this rotation. And I was thinking that the car could be in the center, and the house is basically on the opposite side of the mall. Okay, now this probably won't compile at first. Yes. We need to get our actual procgen. Okay. Great. This is actually fantastic. I know it doesn't look like much, but it's fantastic. Let's just back off the camera a little bit. I think the camera has a zoom. And I'm just going to turn on the air conditioner here. I hope that it won't mess with the noise. I apologize if my audio quality is not that great. Boy, I can hear it now. I think this is going to be too loud. I'll just leave it on for a minute. It's quite hot in this room. Camera direction. Oh, I see. Okay, so with set camera direction, I just have to put this a little bit further out. Let's try this. Ba-ba-da-bum. Okay. So, I have a little bit of a vertex sorting issue on our cubic render function, procgen box. Like I said, I hadn't tested this. So I think that I just have to put some of these in a different order. Let's try this. It's funny, that looks exactly wrong. I think if I turned off backface culling, let's go ahead and try this. Oh, these darn commas. I wish C++ let us put a trailing comma in there. It'd be so much easier. Okay, this looks more correct. The shading leaves something to be desired for sure. Alright, let's reposition these objects. I'm going to rotate the shopping mall 45 degrees. Oh. Looks like we're either not seeing the house, or maybe we're not seeing the car. Put 30 here and see if the car shows up. Well, I think we want to change the shape of some of these anyways. I want this to be 0, 0. And so this is a focus camera, so the camera is focusing on this point, and it has a direction of here, which, in the future would probably want to pass that in as a vec3. But for some reason we're not doing that. Yeah. Same thing here. So we're kind of looking like the camera is positioned at this location, and it's looking at this location, which maybe is a little bit seems a little backwards, but maybe I can rename these functions to make that a little bit more clear. We're procedurally generating these boxes, storing them as meshes, and then the game engine knows how to render them. And again, the shading leaves a lot to be desired here. Let's see. So let's make the house more square, shopping mall more boxy. What's a more realistic dimension for a car? 5 meters, 6 meters? 2 meters tall, that sounds about right. I think I commented out the car. What is going on here? Oh, maybe that was the house. Okay, let's zoom out even further here. See what that looks like. This part can be a little bit frustrating. Getting camera positions, trying to find everything, if you know what I mean. I want to see just the car. Okay. So I think it's the house that for some reason we're not seeing. Oh. Okay. So it looks like that is the house. Let's swap it to the kind of the other side there. Great. So we want this to be, but we must not be seeing it. Maybe it's too far away. So where is it? We can, let's make the car red so that we can find them. Maybe we'll make the house a little blue. Is shopping mall too big? Why are we not seeing it? The hardest part of 3D game development is finding that first triangle. So we have the first triangle at least. That's very good. There's the car. That red became a pink color. Let's make that a bolder red. Well, the shopping mall seems to be what's missing. I noticed that the shopping mall is much, much bigger than the other ones. So let's just bring it back down to a more reasonable size. Basically the same size as the house. See if it shows up. No, what's the problem here? Mesh house? Oh, I think I know what the problem is. I should really address this. Okay, so U32 null mesh equals store mesh. How do we do that? Because this is something that I shouldn't have to deal with on a per game basis. Okay, so I just make quad and store it as a null mesh. And for some reason, the first time you generate a mesh, the mesh number is 0, and that's interpreted as a null mesh. Which, why does it work that way? That's silly. But I won't try to fix that on camera. I think that's just kind of a strange detail. Okay. Now we can go back to a little bit closer to the dimensions that we were talking about. 70, 100, let's say 10 meters tall. Okay. Oh, and shopping mall. Okay. All right. Nice big shopping mall. I'm going to set the camera even further away so we can have the shopping mall kind of, a good distance. Let's see what that looks like. Okay. Well, I want to get a little bit more of an angle, especially in the Y direction. And we can keep stepping these further away. Hopefully we won't lose sight of them. There we go. And that looks basically acceptable. Let's rotate the house a little bit so it's easier to read. Okay. Good. Good. I just want to add the parking lot, and then we can start to think about how are we going to do this curved mesh that represents the road. To be honest, I haven't even thought about that. I might stop the video and think about it in the shower and come back. But let's get this parking lot. We need it next to the shopping mall. Let's say and then negative 290, and we'll keep it at the same rotation. With a 45-degree angle, we're stepping at 10 meters in each direction, so it should kind of line up. And then we just got to get the size right. Mesh parking lot. And its size is what? In the long dimension, it's going to be the same as the parking lot. In the short dimension, it's going to be, or in the z dimension, the up direction, it's going to be very small because it's a thin layer. And maybe it could actually be the same size in. Well, let's try kind of smaller a little bit, and we're going to make it a darker color, still gray. Okay, did I get all that right? Well, I don't see anything. Let's see. It might just be entirely overlapping. Yes, okay. So we just got to move it probably quite a bit more. Actually, I'm going to move the shopping mall back. Let's move it back more than that. What do we start at? 30. So let's go 50, 320. And I'll move this in even more. Okay. Okay, we're getting somewhere. Okay. I think I made a conceptual error in how I'm generating the boxes. In the Z direction, oh, for one thing, these are twice as large as I ordered. So now everything's going to shrink in size by half, I think. Yes. Isn't it nice how things work in computers? Everything's so clean and organized. Okay. I must have made a counting error here. It feels to me like this needs to come in more. I don't know why that would be the case, though. And I think it should be wider. I'm going to bring in the camera just a little bit. I might make things larger again. Well, okay. We can kind of zoom in on the shopping mall. 15, negative 300. Let's actually keep it at 0, but go to negative 300 here. And we can zoom in. It still looks like the shopping mall is kind of like sinking below. I wonder if my camera's just kind of upside down. No, I don't think that was the issue. Although I guess I have to set the up direction, don't I? Okay. I don't know. It looks wrong. I think I'm gonna have to get into terrain before I figure out why that looks wrong. But we got a start of something. Let's go back and try to get that demo. Try to get that demo perspective. What does that look like? What does that feel like? I know it doesn't look like much right now. Just trying to take a look at. Up this to -20, shift it over just a little bit in the X direction. That does look somewhat better. What does it look like if I shift it in the Y direction? I like them to intersect, you know? Then we can tell the mall is being rendered too high. Okay, I'm gonna try an old trick. I'm gonna ask AI. I'm gonna phone it in. Too lazy to think about splines today. This is code for my 3D game engine, which generates the mesh for a box cube. I want to add curved roadways to the game. First, will probably be splines. We want to make a mesh generator that creates a flat curved roadway. We also want to make a spline struct class, which which stores the parameters for spline. The roadway should travel between. Where do you want the road to go? Between 0, 300, 0, and 0, negative 300, 0. Along a curved path of some sort, and its dimensions should be 10 meters wide and 1.5 meters thick. Let's see this out. It generates a curved roadway mesh following that path. Project curved road creates divides the road into 12 segments that generates a mesh using mesh layer. Please use sneak case. Case for okay. Now we're going to pass this into the AI, and this AI is even smarter than GPT-4. It's actually pretty good. So it has a spline. This looks like, I guess it's a cubic spline. Okay. It wants to get this math.h. That's alright. We'll probably put some of this in its own file. Procgen, a curved road, dividing it into segments, finding the point on the spline. You know, I feel like okay, this code isn't going to work correctly because it's trying to get vertexes kind of from the future. Current base, next base. Okay. Let's tell the AI about this problem. Because of the way that I've written mesh filler, this code will have some issues. It uses vertices before pushing them into the mesh filler. Current base plus force. Let's see, how's it doing? Where's his current base? Current base. Let's do this automatically. visual items, the process to be added before they are used in Claude. Let's actually look at the code and just double check that. I don't know if this actually would be. Let's just see how Mesh Builder actually works. So in store, it goes through the triangles. X. You know, I guess I'm actually wrong because it stores all the locations of the triangles. And then when store is called, so, you know, the AI is, maybe it's smarter than me. Okay, let's take this code and dump it into a Spline class. That's cpp. And let's also put it in a .h file. Well, that's very nice. It didn't put the functions on the spline, which is kind of my coding style. Although I do make exceptions for that sometimes, because sometimes it's just sensible to have an object that, you know, you can operate on it. Okay. 8 down. And then we're going to go into our game code and store this. I think we're going to store the road spline globally because we're going to use that to interpolate the position of the car. Isn't this nice? AI is saving us a whole bunch of time. I hope this actually compiles. We'll just store mesh road. Road spline. Okay. We're going to put the road at 0, 0 with no rotation. We need a spline.h. Now, if AI did this right, it'll all compile. Of course it won't. I didn't actually. There's a bunch of headers that I'm missing here. H for GLM. I should probably put a dedicated header to include GLM. And then in the CPP, you have to include, actually, include the header. And we don't need to define this twice. And back here, we don't need this. We also need Mesh Builder. Mesh Builder, we're probably going to need Mesh. Oh. Must think that we're using a different math library. It didn't pick up that we're using GLM, so it thinks that there's this math back add. Okay. Well, we can just do this. Right, times half width. And if we ask the AI again, wait, hold on a second. Op times thickness. Okay, because we can't multiply two vectors together. I just want to make sure that we're not multiplying two vectors here. Was there a vec3 add? Oh, these are all vec3 adds. Okay. change this into a plus sign. Oh, I missed a comma there. Vec3 neg. Where is that? 59. Multiple definition of road spline. How do I put this here? Okay. Well, that's something. Maybe that issue that I was complaining about is an issue. Yeah. Kind of want to see this from a different angle now. Isn't that wild? 3D graphics has some weird glitch modes. It looks like it kind of follows a nice path here. But it's all of the points are kind of going back to one point. So let's go back to maybe, can you find some way to fix this? Mesh Builder needs to, before they're used in a quad. So let's try it. Also, our Vec3 library is GLM, so you can just add and multiply like v1 plus v2 times scalar. We don't use Vec3 mul, Vec3 neg, etc. Okay. No need to apologize, AI. It's really a deficit in the way that I've written this class. Okay. Vertex. Cool. So it's going to pre-calculate all of the vertices. You know, I should have committed to Git before I got into doing the spline stuff here. Isn't that a big time saver, though? It would have taken me a whole day to figure that out on my own. Okay, this looks like progress. There's something off about the shading here. But it is very nicely curved. It's got a nice shape to it. We're going to have to reposition that mall. Okay. Okay. Let's go ahead and make a commit here, just so that we can clean up our workspace. We have Splines, the 2000 demo. And I want to go ahead and look at this from a different angle. Just gonna move the camera. This one is the overview. And here we're gonna zoom in on gonna look at it kind of from the X side. What is going on there? 30. This is the close up. Okay. I think we want to look at it. So I can do one of two things. I can try to, debug this as is, or I can try to start to implement the camera. Let's see. I think I started to implement a camera in a different game that I'm building on the same platform. And in this one, I must do the mouse input in a different in the main file here. Let's just take a look. Golden event handler. Mouse move. Oh, I call mouse move in every frame, and use GLFW get cursor pose. So I don't really have an abstraction layer for input handling, but I think that I'm going to implement that pretty early on because that allows us to get key mappings, and it is good to sort it out in the beginning. But right now we're just using GLFW. Getting the cursor position, and then using that to rotate the camera. So a simple thing we can do is when we do the drawing, we can also position the camera. Position camera based on the mouse position. Let's see, how do we do this up here? 64-bit floating point. And we want to position the camera, that camera direction. And do 20 times x minus 10, 20 times y minus 10. I think that x and y go between 0 and 1. I hope it's not the whole window size. Let's see how it's used here. Okay. Well, that does something weird. Let's just figure out what we're working with here. Okay, so it is more like the size of the window. Okay. Win X, win Y. Doesn't AI save us so much time here? Isn't that convenient? Really? They make these integers and the other ones are floats. It's... And now we can kind of move the camera a little bit. This is not any serious implementation of the camera, but it allows us to, see the scene from different angles. The way that I have the camera up working here is obviously doesn't make sense. Although this is a cool visual, isn't it? It would make a great game trailer. Wow, wow. Okay, so is this a vertex ordering issue? It looks like that to me. Let's just take a look at how the AI set up those vertices. Actually, let's get that back here. Just going to take a look at how the AI set up the vertices in the spline class that it set up for us. So create some vertices. Okay, so it does create a bottom face. If we turn off that bottom face, it'll be clear what's going on. The top face is missing one of the triangles, which is usually it's an ordering issue. Just for reference, I'm going to keep. So what if we change the order of this? Exactly wrong. Perfect. So then we just got to change the ordering of these two. These vertex ordering issues, they're just a constant companion in the... Wow, isn't that great? Look at that. Maybe I will use this camera angle for the trailer. Because it is quite entertaining, isn't it? Okay. So, wow, that's great. So let's just amend our commit here, get a clean workspace again, and we can start thinking about how to make a little animation. So first I'm just going to make the car go along the road. And here's the car, and so before we position the camera, now I think I have a way of recording the time. So first we got to figure out a way of recording the time, how long the animation has been running. So we can have an animation, we need time. And I don't think we have a concept of time now. We do have this tick. What I want is a frame duration. Now, not actually using the tick in this version of the engine, but we can take a look here. The execution engine here. And so we want to get the time from GLFW. I don't remember what type it is. It's GLFW get time. Where's my AI? GLFW get time. Looks like I use it as an F32. So we get current time F32 last time equals GLFW get time. F32 delta equals current time minus last time. And then we have to start an edit here. Commit the edit. T at as to tick right. Actually, let's do this. So the way that this kind of in-game database works is you have this T object, and you can use these functions to, it's basically like a tree, and you can use these functions to look into the tree, so you can look at the tick location to get another cursor, and this is actually a cursor of I32 because it's being transformed into an I32 type. And then we can say tick dot write tick dot read 0 plus 1. Now, the way that this is structured, there could be multiple ticks, but I don't know why you'd want to do that. And we're going to do something similar here for t dot attaz F32 at the location frame duration. And we're going to write, I think we need to write 0 and then delta. The frame duration and tick. And then, because I just want to verify that this is going to work, I'm just going to use printf here. I have a way of displaying it to the screen, but right now I'm just going to use printf. Frame duration. Actually, let's just get a 32 frame duration equals t dot attaz F32 frame duration. And I know that this might seem like a very cursor syntax to read from a database. I'm sure that it's going to be very confusing to newcomers. But under the hood here, I'm dealing with so many problems that are big headaches for game developers. I'm dealing with memory management, I'm dealing with multi-threading, and I'm dealing with multiplayer. And I'm dealing with serialization, meaning saving the file to disk. So let's just see if we can read the frame duration. What did I get wrong here? Okay. Tick cursor. Try that again. Well, that's time equals current time. I don't know why it would come up with a 0 for that, though. Well, now it's giving me... That doesn't even make sense. Well, now what's going on here? Last time equals current time, delta... What did I get wrong here? Where did I go so wrong? Choosing C++, choosing to do this kind of work. Well, now we're getting a reasonable value here. I think that this might be just that I'm doing my database in a very strange way. So here's what I'm going to do. I don't understand what the problem is here. My super cool, awesome database from the future is not working correctly. Not working yet. It'll be working correctly in the future. I assure you. So I'm just going to ignore the database for now. And we'll just calculate this all here. F32 last time. Time equals GLFW get time. So we'll just store some camera values outside of the database, and I'll figure out some way of fixing the database. Probably I won't do that on camera though. Equals frame duration. Now we want to interpolate the location of the car along the spline. How did the AI set this up for us? Evaluate spline tangent. That's interesting. So it gave us a way of getting the tangent too. That's useful. So vec3 car loc equals evaluate spline road spline camera time divided by 20. Let's see how we feel about that. And then here we do car loc.x, car loc.y. And z is going to stay 0. And it won't rotate. Hey, there it is. Wow. Look at it go. It's upside down, but it's going. And it's not rotating, but that's okay. And it goes right to the mall. Ain't that great? And it keeps going. So I think we want to clamp our spline. go ahead and disable the very cool camera for now. It's 0f 1.0f. Clamping the spline between 0 and 1. This camera is now too close. The car looks fine. Do you think it needs to rotate? I guess we could use the tangent to rotate it. Okay. That's very good. I'm actually going to set the camera to follow the car. Car load. Why does it need a VEC4? There. 0F. And we can see that the spline clamping works, so the car stops kind of in the parking lot there. Now the camera follows the car. We have some weird shading going on here. Off camera, I changed the shading algorithm a little bit because I was trying to get some better shading going on here. Like I said, 3D graphics has some really strange glitch modes. Let's go back to our kind of close-up here. Let's see how we feel about this. Okay. Let's go take a look at this shader code, and maybe we can disable the specular. If I recall correctly, it is in render.vert, not in the fragment shader, but in the vertex shader. So we're kind of doing flat shading. Well, if we just turn off the specular, maybe we won't get those glitches. Just for now, yes. I think that's a little bit too zoomed in there. Okay.